Alright, I'm back. Mr. Angus Wangus here. I've got a vid for you, and just want to start by saying, I know I've said it a million times, that I'm going to have more free time, yada yada yada, right? But now it's really happening, you know. Things keep coming up, but now it's really starting to happen. I'm going to be out squatching too, more. Oh, cool stuff going on there. I'll have a squatch vid coming in a day or so about that. And let's see. My last energy type vid here was Ring the Bell Twice about Ed, and he had the Ring the Bell Twice written on in the front of his castle, and I was speculating what it's about, and I talked about the tank circuit and resonance and electrical system in that sense, and that I wanted to carry on with my experiments here. I showed the variable capacitors Ed had in his tool room and explained how that's the direction I was heading, right? So I'm there, yay! So I'm getting more time to do this now, so I'm all excited. But, and little East over here is in the shadows. He's the dark sheep. But getting more time to delve into that. I've got my wheel going here just to start out with. I'm going to click it off just for, so it's not all loud. But this video I'm making is entitled Electricity Limited versus Unlimited Power Sources. Now for me, the best source for this info is Eric Dollard here on the net, or on YouTube. Type him in, Eric Dollard. Filter the searches maybe to longer vids, and you'll get good lectures of him. But I'll try to remember to leave a link to his lecture where he talks about everything I'm about to talk about, and how our power measurements from generators that we make probably aren't accurate as we do them using the standard volts times amps technique. This is what I'm gonna attempt to talk about here in the video today. Hopefully. Kind of hoping it opens a can of worms that sort of needs to be opened, in my opinion. But also, I don't want to fight about it. You know what I mean? I'm learning, and we're all learning, right? So, nothing to get all excited about what I'm about to say, but that I do anticipate maybe some people won't want to accept it or fight it or whatever. Maybe not. Maybe I'm wrong about that. Who knows? But anyways, there are two types. We have electrical power sources, and we have a couple types. Two basic types: unlimited power sources and limited power sources. And I want to talk a little bit about each today, and the difference in and how that relates to our generators that we make and how we measure power. Now first, let's look at this unlimited power source, right? I'll zoom around a touch. So with the unlimited source, it's basically your socket, your wall socket is the prime example of this, right? It's an unlimited source, basically, whether it's hydroelectric power, nuclear power, wherever it's coming from. You're never going to knock that current down to where the voltage depletes, right? It's always going to stay at that voltage. Even if you have, you know, even if you don't have a breaker box in your house, you're not going to pull it all out to deplete voltage, right? Basically, it's a bottomless pit without a breaker box. Even you can't put a load on it big enough, basically. So when you plug, say, a power source into the wall and run that and do tests and experiments and things like that, when you measure your, okay, let's say you've rectified this AC wave, you've rectified it into DC. When you measure the amps and the volts and multiply them together to get your watts or power, it's going to be fairly accurate, right? It's going to be a fairly accurate measurement. Still sort of a guesstimate, but it's going to be a fairly accurate measurement, right? But with the limited power sources, well, first example is a generator wheel with magnets on it. Could be solar panels, could be a wind turbine you have hooked up to battery banks with an inverter. It's going to be no difference. The actual source is limited though, and the wheel being limited by its speed and whatnot, which may depend on other things, but given that things are fixed, magnet position, say on the wheel, or speed of the rotor, or number of solar panels, amount of sunlight hitting it, amount of wind hitting your wind turbine. As long as you're talking about fixed numbers, you're going to have a fixed or limited power source, right? And what I want to talk about is the difference between the two, because a lot of us like to make these generators, and we generate power off of a wheel or other ways. the way I'm interested in, if anyone watches, or what I'm working with are generator type setups with a spinning wheel with magnets on it and coils. But basically, with your unlimited power source, let's just have a look at both here. With your unlimited power source, the AC power measured, you want to do that with a watt meter, and that's the best way to do it. So, okay, say there's no bridge rectifier here, and you want to measure your power of this AC current. You use a watt meter or an energy meter, right? That's going to do the calculation for you, give you your watt usage, right? And you know, we all know that, and hopefully, and that's the best way to measure your unlimited power source, unlimited AC power source. Now, if you have an unlimited DC power source, okay, let's say we had a rectifier in here after our power source, a rectifier, and we measure amps and volts, and we multiply them together. Because it's an unlimited power source, this way of calculating the DC energy used or wattage is going to be fairly accurate, like we just mentioned a minute ago. So that's going to be in this instant, if we rectify it and measure the DC in this traditional manner, it's going to be an okay method. Now, going over to the limited power sources, the AC power measured. Imagine this full wave bridge rectifier isn't here, and we have AC power. We're measuring just AC power. The best way to do that, same as over here, measuring the AC power, the best way to do that is with an energy meter or watt meter that does the calculation for you and the power factor and all that. That's going to be okay for measuring your AC current. And we know that, again, same thing. These are things we know. But mainly what I want to point out in this video, the whole point in this video, finally getting to it, is that with a limited power source, a limited DC power source, so we have this full wave bridge rectifier here, that's what that thing says there, FWBR. With a limited power source, a limited DC power source, we're going through this full wave bridge rectifier, to measure amps and volts and multiply them together with a limited power source is not going to be accurate in most instances. And I'll explain why. The DC, even if you want accurate measurements with a limited power source, coils next to a wheel, right, generator, if you want the most accurate measurement with a limited DC power source, you want to use an energy meter or a watt meter or whatever you call it. You're going to want to use that in the system to measure your power used. And I'll explain why. Why the difference with the limited DC? Why am I saying there's a difference? So if we had a rectifier here with the unlimited source, if we measured the amps and volts, multiply them together, it's going to be fairly accurate. But if we do that in the limited power source, it's not going to be accurate. And why? Why is that? Well, shorting the coil shows this best, I think. If we were to short this coil, right, with the limited power source, all the current is going to go through that wire and through the coil. It's a short. It's going to be the highest current. And if you do that with your generator or whatever, you're going to see the current spark, and you're going to see the power that's in there. If you touch it, you know, you're going to feel it too, right? So with the short, you short it out, it's the maximum current that's flowing in there. What happens is your volts go to 0. So the short, if you short that coil in the limited as a limited power source, all the current is going to be flowing in that wire. The potential before you measure it, the voltage potential, you know, that's showing is going to go to 0 when you short it, and it's all going to be current. Shorted with no load. Now, less than a short. If you have less than a short or a load, right? The load or resistance, you have a resistor in here instead of just a short. Now, instead of a voltmeter going to 0, like with the short, if you had a voltmeter on, it goes to 0 and it's all current flowing in that wire. But if you have a resistor in that circuit, right, and close the circuit, then instead of the volts or voltmeter going to 0 and it all being current, there's going to be a voltage of some sort across that resistor, right? So now this gives a value, and it's dependent on the resistor. So a limited power source, this tells us that a limited, sorry about the trucks, I guess a school bus. So the limited power source, where was I? So with the limited power source, the resistor, the value, the voltage value when you measure it is dependent, or the power going through it is dependent on the resistor, right? And we know that. We know that already. But this, we're talking about specifically the limited power source though. So that brings us to voltage and amperage, right? Voltage equals the potential when you measure across the load, or if there's no load, you measure the terminals. Measuring the terminals of the battery is the same analogy. You're measuring the potential, the voltage or potential. And the current is equal to the flow, flowing in the wire, right? The actual flow in the wire is the current. So as more current, so as there's more current in the wire, flowing in the wire, right? You have less resistance. The voltage approaches 0, right? So if you have a smaller and smaller and smaller resistor, tiny, 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 approaching infinitely small, approaching 0, like in calculus. If you have a resistor that's approaching 0, right, your voltage is also going to approach 0, right? So with more current flowing in that wire, the voltage approaches 0, which in the traditional volts times amps calculations makes the wattage calculation, because that's what volts times amps gives you, is watts in DC power. But if your voltage is approaching 0 with the traditional volts times amps calculations, this makes the watts go down and approach 0 as well. So as your volts go down, right, your resistor goes down, approaching 0, that makes your voltage go down, approaching 0, which also makes your wattage go down, approaching 0. But, big but we know that the current went up, right? As we get closer to a short, there's more current flowing in that wire, right? Less potential and more current in the wire. So there's more power flowing through that wire. And again, all you have to do is touch it. Put a resistor on it and touch it, and then take the resistor off and touch it. That's a very simple but yet practical test. You can prove to yourself what I just said is true. So we know that the current went up. And there's more energy flowing in that wire as current available to do work. So with a very, very small resistor approaching 0 and voltage approaching 0, this would make traditional calculations show wattage approaching 0 as well, right? However, wattage and work done would actually be increasing as that current increases, right? Available energy for doing work, right? There's more there. There's more wattage. There's more potential for work to be done as the current increases in that wire. So, however, wattage and work done would actually be increasing, right? So your wattage calculation would be approaching 0, but your wattage actual reflection on your workbench of work done, right, is going to be increasing as this resistor decreases and this becomes more closer to a short. Now, this is why when batteries are used as a load, for example, they act as a voltage regulator, right? The plates in them act as a voltage regulator, knocking down or converting voltage down into amperage or current, right? So that battery doesn't allow the voltage to go to 0, right? It's using some of it. So if you increase the load, voltage means that an increased voltage is not being converted, right? So if you, let's say, have a battery on here that's 12 volts, let's say your available potential was 20 volts, and you put a 12 volt battery on here, this 12 volts of that 20 isn't being converted into current. It's the battery is acting as a voltage regulator and keeping it won't let it go below, say, 12 volts or 13 or whatever it's energized to. As opposed to, say, a smaller resistor. See, the battery acts as a resistor, but it also acts as a voltage regulator. It also has capacitance. Batteries are pretty cool things. But the increased load voltage, say a 12 volt battery, means that there's increased voltage is not being used. So the equivalent amount isn't being used. So actually, representative 8 volts of that 20 are being converted into current, right, at 12 volts, if that was a 12 volt battery. Now, if you were to short that, right, and have it all to convert to current, right, or have a very, let's say a 1 volt battery on here, a 1 volt battery, that current, more of that 20 volts would be converted to current, right? Only 1 volt would not be. So you'd have heavier current flowing through there, and you'd watch your 1 volt battery charge very, very, very well. So also, this means the difference between the load voltage, right? Saying this is, say, a 12 volt battery. So the difference between the load voltage and 0, right? So the difference between, say, 12 and 0 would be proportional to the lens drag, right? For this given 20 volt, for example, system. When the load voltage approaches 0, let's say you don't have a 12 volt battery on there, let's say you have a half a volt battery on there. When you hook this up to your half volt battery, more current's going to flow through, and there's going to be less lens drag. You're going to really charge your battery really well. So lens drag would also approach 0. So it's proportional. The difference between the load voltage and 0 would be proportional to lens drag. So when the load voltage approaches 0, lens drag would also approach 0. I hope this wasn't confusing. I kind of expect it might be. That's why I'm going to include the Eric Dollard video. Now it's a long lecture, and I can't remember exactly where in the lecture he covers these particular things, but he does very beautifully in the lecture link I'm going to leave. But mainly what I want to say is that in a limited source, electrical source system, that's a limited source, your volts times amps calculations you're going to find aren't going to be accurate, right? They're just not going to be accurate. It's resistance or load dependent. It depends on the resistor and the number of volts it requires from the source is what it's dependent on. And as these numbers approach 0, the power doesn't disappear as the wattage calculation disappears as well, or approaches 0. The current increases actually in the system, right, in the wires. So you'll find ultimately that this system is not accurate with limited source systems. Again, hope it's not confusing. There's going to be a lot that I left out. We can hash it out in the comments, right? Everyone be kind, and I'll be kind too. I promise. And fun to think about, though, because there's going to be a lot of things I forgot to mention. I know there is, and things I could have said clearer as well. And maybe carry on discussions about the Eric Dollard video. But again, I'm having more and more time to work on my projects, and yippee, and I'm resuming where I left off. I was talking about Ed's setup and resonance, tank circuits, LC circuits, however you want to call it, and his variable capacitors, and he was using variable capacitors to find resonance. He was tuning frequencies. So that's what we're going to do. And I'll have more videos to come, and I'll have more Bigfoot videos for sure too. I got lots of exciting Bigfoot things going on in my mind now too about my location. But anywho, let's talk about limited versus unlimited sources, and I'll be back with my projects, more vids, more frequently. Thanks for watching. This turned out longer than I wanted. I already know it has. Thanks for watching and being patient. I'll talk to you later. Bye.